Hello all, welcome to iRise online classes. One of the leading institutes for SSC, CGL, SI and constables for Telangana as well as the AP states. Right. So today we are going to start about the general science part. So the general science includes physics, chemistry as well as biology. So I'll be dealing with physics as well as the chemistry. So speaking about myself, my name is Sudhir and I'm handling physics as well as chemistry for SSC, CGL, at the same time UPSC preliminary examinations for all the competitive examinations for the past 10 years. Right. Now when talking about the case of physics and chemistry, physics as well as chemistry. Now in the case of physics, these are the topics that we are going to discuss. One is mechanics, sound, light, heat, electricity as well as magnetism. So this particular topic, mechanics, basically speaking, it's a very broad topic. Now all these particular topics, mechanics to magnetism, all these particular topics have to be covered based on the NCERT textbooks from 6th to 10th classes. 6th to 10th classes. Now if at all you are thorough with the basic science from 6th to 10th classes of the NCERT syllabus, NCERT textbooks, at that particular point of time you will be 100% thorough with all the basic part. Now we're talking about the case of mechanics. In the case of mechanics, we'll be dealing with units, kinematics, work, power and energy, work, power, energy. At the same time, one more broad topic which I call it as a fluid mechanics. So in the case of fluid mechanics, we'll be discussing the Bernoulli's principle, Archimedes principle, right? So at the same time, surface tension, viscosity and all those topics we'll be discussing in the case of fluid mechanics. Now all these particular topics are put into one particular topic which we are saying it as mechanics. Then the remaining topics, sound, light, heat, electricity as well as magnetism, all these particular topics have to be discovered have to be discussed up to the 10 standards. Right? Then when you're talking about these particular topics, how to read, what to read. So for the SSC examination point of view, where you are expecting around 4 to 6 questions from physics and chemistry, right? Any particular question which is having the application part, all these questions have to be discussed keeping in view the application, at the same time the concept oriented, right? So for SSC point of view, we did not discuss the equations, we did not discuss the basic formula behind it or else the problems behind that one. But at the same time, keeping in view the SSC, SI as well as the constable examinations point of view, you are expected something in the range of 10 to 15 questions for SI as well as the constables. Now when talking about the SI and constable, sometimes there is a rare chance that you are expected even some problems on basic things. The basic problems where you are supposed to calculate the initial velocity, final velocity, or else the amount of work done, or else the amount of current that is flowing through a circuit, some basic concepts, some basic applications. So we'll be discussing all those things in the course of time. Right? Now coming to the case of the syllabus, the first topic that we are going to start, right? The first topic that we are going to start is units. Now this particular thing is a basic and the fundamental thing for all the concepts that we are going to discuss in the case of physics as well as chemistry. So any particular term that you take, suppose that you're talking about velocity. Velocity we cannot say simply as 5. You need to write some units for that, right? You call it as 5 meters per second or else you write it as 5 centimeters per second. At the same time when you're talking about energy, right, you say 10 joules or else you write it as 10 ergs. But you need to specify whether it is 10 joules or 10 ergs or else 10 watt, right? You need to specify something, or else you cannot write something as simply 10. 10 does not have any significance or meaning in the case of physical sciences. So as long as the unit is not mentioned, it does not have any particular significance. So that is the reason why each and every particular topic that we are going to discuss in the case of physical science, we talk about one particular thing called as units. And when talking about the case of units, the first and foremost thing that we discuss here is about physical quantities. Physical quantities. Now, what is a physical quantity? What is a physical quantity? Any particular quantity which is measurable. Any particular physical quantity which is measurable, that is what we call it as a physical quantity. Right? For example, right, when talking about the examples for physical quantities, when talking about the example of this one, right, we give it as length. You talk about mass. You talk about work. You talk about energy. All these, you can give n number of examples. You can give n number of examples. Now all these are nothing but the physical quantities. Length can be measured. The length of an object can be measured. For example, suppose that you have got an object here in my hand. Now the length of this particular object, you say that it is something around 15 centimeters. Right? Right? Or at the same time, the weight of this particular object, we say that it's around 10 grams or 20 grams or 30 grams. Right? The weight of an object, the mass of an object, the amount of work done, right? The amount of energy that is required to do work, right? All these particular parameters can be measurable. That is the reason why we said that all these things, they are nothing but physical quantities. So any particular physical quantity that is measured, any particular quantity that is measurable, that is what you call it as a physical quantity. Any quantity that is measurable, you call it as a physical quantity. And these particular physical quantities, you divide them into two categories. The physical quantities, you divide them into two categories. One is fundamental quantity. The other one, derived quantity. Fundamental as well as derived quantities. Now when talking about the first category, that is what? The fundamental quantity. What are fundamental quantities? The quantities which are completely independent of any other physical quantities, we call them as a fundamental quantity. So any particular physical quantity which is completely independent of any other parameters, we call them as fundamental quantity. Now for example, suppose that you take the case of length. The length of an object. The length of an object is completely independent of all parameters. The length of an object is not dependent upon mass. The length of an object is not dependent upon time. It is not dependent upon force. It is not dependent upon speed or velocity. Since it is not dependent upon any other parameters, we say that length is a fundamental quantity. Now, apart from length, we have got some other quantities. For example, you talk about the case of mass. The mass of an object. The mass of an object is completely independent of all other parameters. That is the reason why we say that mass is also a fundamental quantity. At the same time, you talk about time. The time taken to do work, any particular thing, the time taken to move from point A to point B, the time taken to move from Hyderabad to some other place, right? So that particular time generally is measured in terms of seconds or hours or days. But the fundamental quantity when you're talking about time is simply we call it as the fundamental unit for this one is what we call it as seconds. At the same time, the mass of an object is generally measured in terms of kgs. The length of an object is generally measured in terms of meters. That is all if at all you're talking about the SI units. Now what are these SI units? What are these CGS units? We'll see that. Then moving on to the next one. That is the derived quantities. The physical quantities which are dependent on fundamental quantities, we call we call them as dependent quantities, or else the derived quantities. The physical quantities which are dependent on the fundamental quantities, we call them as derived quantities. Now for example, suppose that you're talking about speed. Now when talking about the case of speed, we write this one as speed equal to distance by time. Speed, we write this as distance by time. Now this particular speed, now this particular term called as speed, it is dependent upon one fundamental quantity which are calling it as time. At the same time, suppose that if I talk about force. So when talking about force, you write this one as the product of mass and acceleration. Force is defined as the product of mass and acceleration. Or else when you talk about the case of work, we write this one as the product of force and displacement. And this particular displacement, what is displacement? The shortest distance between any 2 points, that is what you call it as displacement. You are saying shortest distance, which means again here you are talking about one particular term called as length. So work is dependent upon length, force is dependent upon acceleration, speed is dependent upon time. At the same time, suppose that you talk about weight, W equal to m into g. So again this particular weight is dependent upon one particular term which are calling it as mass of an object. So these particular terms, speed, force, work, weight, suppose that you're talking about one more quantity which are calling it as impulse. Impulse equal to force into time. This is again, the impulse is dependent upon time. Now we talk about the case of one more quantity which you call it as momentum. Momentum, you talk this one as mass into velocity. Momentum of an object is mass into velocity. So all these particular terms, either they are dependent upon fundamental quantities, either directly or indirectly. In some cases they are dependent directly, in some cases they are dependent indirectly on that one. So whether directly or indirectly they are dependent on fundamental quantities, that is the reason why we say that they are derived quantities. The quantities which are dependent upon fundamental quantities, we call them as derived quantities. The quantities which are completely independent, we call them as fundamental quantities, that is length, mass as well as time. So these particular terms, length, mass and time, we call them as fundamental. At the same time, when you're talking about the case of your impulse, momentum, speed, force, work, acceleration, all these quantities, they are nothing but your derived quantities. Now whether it is a fundamental quantity or whether it is a derived quantity, whether it's a fundamental or else whether it is a derived quantity, so when you want to express the units of those things, we write them each and every particular quantity in terms of some specific term, we call them as units, right? So for writing that particular units, we have got a system. That is what we call it as system of units. Now this particular system of units, basically we have got three different types. One is the CGS system, then FPS system and MKS system. So these particular, what are the fundamental quantities? One is length, then mass. Length, mass and time, these are the fundamental quantities. Now for these three fundamental quantities, we write some fundamental units. Now when talking about the case of length, the length of an object in CGS system is measured in terms of centimeters. The mass of an object in CGS system is measured in terms of grams. Time in CGS system is measured in terms of seconds. Whereas in the case of FPS system, length is measured in terms of foot, mass is measured in terms of pounds, and again time is measured in terms of seconds. MK system, length is measured in meters, mass is measured in terms of kilograms, time is measured in terms of seconds. Now this particular MK system, the modern expanded form of MK system, is what we call it as the standard international system, which we are using throughout the world as of now for all the exchange processes or for all the purchasing or for measuring any particular quantities. We are using as of now the SI system. So even in the case of SI system, length is measured in terms of meters, mass is measured in terms of kgs, time is measured in terms of seconds, right? So this is what we call it as the system of units. Now according to the SI system, right, according to the SI system, we have got 7 fundamental units. Now when talking about the case of fundamental units, we just said that only length, mass and time, they are the fundamental units. But as per the SI system, we have got 7 fundamental units. As per the SI system, we have got the 7 fundamental quantities. At the same time, for all the 7 fundamental quantities, we have got 7 fundamental units also. Right? As per the SI system, we have got 7 fundamental quantities. Now for example, suppose that here I am talking about some fundamental quantities. This one. Right. Now here, as per the SI system, we are having 7 fundamental quantities. The first one, we are talking about length. Length is always measured in terms of meters, mass in terms of kilograms, time in terms of seconds, temperature in terms of Kelvin, electric current is measured in terms of amperes, luminous intensity in terms of candela, quantity of a substance is always measured in terms of mole. So these are the 7 fundamental quantities, their units, SI units, at the same time the symbols for all those things, right? Please do make a note of these things, right? Length, mass, time, temperature, electric current, luminous intensity and quantity of substance. These are the 7 fundamental quantities. At the same time, their units as well as the symbols, right? Then, now apart from these fundamental quantities, we have got two quantities which we call them as the supplementary quantities. Now these supplementary quantities, right? Now suppose that you're talking about the case of plane angle, right? Plane angle as well as solid angle. Now these 2 quantities which are calling it as the supplementary quantities, the plane angle as well as the solid angle, they have got units. The unit for plane angle is radian, the unit for solid angle is steradian. But the thing is these two are special, since these 2 particular quantities, they do not have any particular dimensional formula, right? Dimensional formula is something different. So whenever you want to express a particular physical quantity in terms of mass, length and time, whenever you want to express any particular quantity in terms of mass, in terms of length, in terms of time, this is what you call it as a dimensional formula. But for the examination point of view, for the competitive examinations point of view, dimensional formulas are not required. Right? So, but the thing is that what you need to remember is that what are supplementary quantities? So, supplementary quantities are plane angle as well as solid angle. When talking about the case of plane angle, it has got a unit radians. Solid angle, it is having a unit of steradian. Now, these 2 quantities, they do not have dimensional formula. That is the reason why we call them as supplementary quantities. So, what are things? So, what is dimensional formula? So any particular physical quantity, if you want to express in terms of mass, length and time, that is what we call it as a dimensional formula. So apart from this, we need to go for different derived units. So when talking about the case of derived units, we have got some number of derived units. So when talking about the case of derived units, we have got almost 50 to 60 derived units. We have got almost 50 to 60 derived units, but from the examination point of view, up to the 10th standard, we require all the physical quantities along with their units, all the quantities along with the physical quantities along with their units, derived quantities along with their units. We need to have a complete list of that. Almost we have got around 25 to 30 derived quantities. So we need to focus on all the derived quantities. Then slides. Right. Now these are some of the derived quantities along with their units. Now for example, when I'm talking about the case of area, now we know that area is nothing but length into breadth, which we write as m square. The area of any particular object, the area of a square or the area of a rectangle, we write in terms of square meters, or else simply we write as m square. Volume, we write as meter cube. Density, kg per meter cube. Speed or velocity, meters per second. Speed and velocity both have got similar units, that is meters per second. Then talking about the case of momentum, the momentum of an object is always, this the formula is also important. The momentum of an object is defined in terms of mass, is defined in terms of the product of mass and velocity, that is kg meter per second. Acceleration, change in velocity with respect to time, the units for that one, meter per second square. So we need to know at least the first 20 to 30 derived quantities as well as the units which are required for the each and every unit. For example, talking about the case of power, the unit for that one is watt. Pressure or stress, both have the same unit, that is Newton per meter square. We have got the modulus of elasticity, torque, thrust, moment of inertia, strain, each and everything. Almost 30 quantities which you need to memorize. Then, now these are certain derived quantities. So when you're talking about the case of units, now as on date, we are talking about some parameters. Sometimes you talk about MB, megabytes, right? Now suppose that when talking about the size of your hard disk, as of now we talk about in terms of TB, that is the terabytes. Now what is 1 TB? What is the value of 1 TB? What is the value of 1 MB? Right? Sometimes when talking about the case of electricity, we write 100 megawatts. 100 megawatt. What is the value of megawatts? Now that is what we call it as multiples and submultiples. That is what we call it as the multiples as well as submultiples. Now when talking about the case of multiples as well as submultiples, this is the case, right? So when I'm talking about the case of 10 power 1, I call it as decameter or simply deca. 10 square, hecto. 10 power 3, kilo. 10 power 6, mega. 10 power 9, giga. 10 power 12, tera. 10 power 15, peta. 10 power 18, exa. 10 power 21, zeta. 10 power 24, iota. Now 10 power 24 is the maximum value that we can measure it as of now. Right? This is the maximum values. So these are what we call as the multiples of SI units. If you observe, here we are talking about the positive powers. Plus 1, plus 2, plus 3, plus 6 and so on. Right? So this is what the multiples of SI units. At the same time, we talk about one more term, that is the case of submultiples. The submultiples of SI units. When talking about the case of 10 power minus 1, that is what we generally do, decimeter, or else sometimes in terms of we write as millimeters. 10 power minus 2, centimeters. 10 power minus 3, milli. 10 power minus 6, micro. 10 power minus 9, nano. 10 power minus 12, pico. 10 power minus 15, femto. Minus 18, atto. Minus 21, zepto. 10 power minus 24, yocto. This is the minimum value that we can measure as of now. So these are different fundamental quantities, derived quantities, at the same time their units, and then the multiples as well as submultiples. Right? A quick look back here. Now we're talking about the case of all these things. First one, we're talking about the case of unit. Any physical quantity which can be measured directly or indirectly, that is what you call it as a physical quantity. Just now I told you, anything which can be measurable, that is what you call it as a physical quantity. Now these particular physical quantities, you classify them into two cases. One is the fundamental quantities, the other one is derived quantities. Right? The quantities which exist independently, the physical quantities which exist independently, you call them as fundamental quantities. Example, length, mass and time. At the same time, you're talking about the case of physical quantities which depend on, this word is important, right, which depend on fundamental quantities. You call them as derived quantities. Example, speed. Now speed is always expressed in terms of distance and time. Acceleration is always expressed in terms of change in velocity with respect to time. Force, mass into acceleration, right? At the same time, surface tension, force into length, different things, right? Each and every particular derived quantity is expressed in terms of length, mass, or else in terms of time. That is the reason why we call them as derived quantities. And the units of those things, suppose that I'm talking about meter per second. Meter per second is a derived unit. Meter per second square for acceleration, that is a derived unit. Newtons for force, that is also a derived unit, right? So these are the different quantities. At the same time, you talk about the fundamental quantities. Now these are certain fundamental quantities. These are certain fundamental quantities based on the SI system. Based on SI system, or according to the SI system, we have got 7 fundamental quantities, and these are all the units for that one, right? Apart from that, then we have seen even the complete list of derived quantities, right? So almost here I have given you 24 derived quantities. This is what is required as per the examination point of view, keeping in view the SSC, CGL, or else SI or constables. If you are thorough with the first 24, this 24, that will be well and good, right? At the same time, you talk about the case of your multiples and submultiples, right? That is what you're talking about, 10 power 6 or 10 power 9 or 10 power 12 or 10 power minus 6 or minus 9, right? This is a brief introduction about what you call it as the units, right? So for the examination point of view, even though we have got certain problems which are based on units, we are not looking into that one, because for the completed examination point of view, you will not be able to, you will not getting those particular questions, right? So these are the 24 derived quantities. So if at all these particular list is not visible properly, you will be provided with the PDF format of this one along with the material, right? So for that there is no need to worry about this. I think as far as I know, these letters are very small, so you don't worry about it. So you'll be getting a PDF for this particular things, right? Thank you.